So this question was originally part of a 2005 question on the AP test, and it compares the caloric intake of students at urban and rural schools. I'll assume you've already read the question. In part A says write a few sentences comparing the distribution of the daily caloric intake for those at the urban school versus those at the rural school. The key here is that we've got to cuss both graphs in a comparative sense. So we can't just talk about where they're different, which students typically want to do, but we have to talk about both graphs, their similarities and their differences with comparative language. So as I look at that, that's cussing the graphs. I can tell the center for the urban graph is lower, even though it's like physically higher, those numbers are smaller. So the urban center is smaller than the rural one. Neither graph really looks to have unusual observations. The shape of the urban graph is skewed towards the bigger numbers, which is skewed positively or skewed to the right, whereas the rural graph is roughly symmetric or uniform. I know this number here is confusing, but we don't want to let one number flavor our whole feeling about it. And it looks like the spreads are about the same for both groups. It's considered a plus if you actually included numbers in here, but not necessarily a requirement. So here I've typed it up for you. Wouldn't have to leave it in this format, but I tried to do it where you can see the center, unusual observation, shape, and spread in that way. Now the next question says, is it reasonable to generalize these findings to all rural and urban ninth graders? Remember this, the results are applicable, or you can generalize them to the larger group from which the sample was obtained, provided that we have a random sample. So if I got a random sample, I can generalize to the larger group from which the sample was obtained. So when I look back here, where was the random sample obtained from? A random sample of ninth grade students from one rural area. So it's applicable to the students at that high school. So we cannot generalize to all students, just to the students at that rural school, and likewise to that urban school. So no, no, this is, these are only generalizable, maybe, to students at the schools where the, we'll call them subjects, were randomly selected. If the schools themselves had been randomly selected from all the schools in the U.S., that would make it different. So now part 3 says we want to look at which of these two plans is better. Which of these two plans is better? Plan 1 says let's just count how much food you eat today. Plan 2 says let's look at how much food you consume over a 7-day period and look at an average, assuming that the records are accurately kept. So don't try to nitpick that method. Just decide, is it better to think about it over a 1-day period or over a 7-day period? Well, plan 2 is going to be better. And the reason is this: on a given day, you might have more a few calories than normal. The 7-day average would average out that day-to-day variability. That's a good word to use in here. There's day-to-day variability. The 7-day average accounts for that. For example, imagine a family that gets together for a big meal on Sunday at lunch or at dinner, but they don't eat the same way on Monday. Or if you're an athlete, there may be certain days of the week when you actually eat a lot more calories, but you don't do that for all 7 days. So this is going to kind of balance out that day-to-day variability. Plan 2 ends up being better. So the next part says let's make some parallel box plots and then verify whether or not there's outliers. So if I go back and look at the original data set, the way that I would probably make parallel box plots, because I can and it's easier, is I'd use my calculator. So let's grab a calculator, type these numbers in, and pause the video. We'll come back from. Okay, so I typed the numbers into my calculator. This is worth noting again. This is 26, 27, 28, 28, 29, 29, 29, 29. etc. for the urban. On the rural side, it's 32, 33, 33, 34. The easiest way to make parallel box plots now is to go to stat plot, make a box plot, and I'll go ahead and make a modified box plot of L1, and then go to stat plot number 2, turn it on, make a modified box plot of L2. It's worth checking that your y equals are empty, and you can see both of these are on. Hit zoom 9. There, uh-oh, look at that interesting point. I've made a mistake. When I look at this list, uh-oh, I got a number 42 on there. There is no 42. Well, there's 3 42s, so this should be another 42. A good way to sleuth that out. You saw how I did that again? I saw one goofy point, and I didn't remember there being a goofy point. So now when I hit zoom 9, there are my box plots. Those look great. Those are parallel box plots. Label them, put a scale, put a title. Now verify whether or not there's outliers. It doesn't look like there's outliers. Why? Because I don't see any little stars out there, but that's crummy verification. So here's what I want to do. I'm going to hit trace on my first one, and I see the Q1 is 29, and this is 36. So I've got 29 and 36. I'll use those in just a second. And then I check out my other one. I've got 45.5, 45.5, and 35.5. So for set 1, the set on top, that is going to be, let's see, that's going to be the urban group. So the urban group, I'm going to take Q3 minus Q1, which is 36 minus 29, which is 7. I'm going to multiply that by 1.5, which is 10.5. And then I'm going to take Q3 plus 10.5 and Q1 minus 10.5. And so that's going to be 36 plus 10.5 and 29 minus 10.5. And when I do that, I get that's going to be 46.5 and 18.5. Now the question is, in this top graph, did I have any points outside of that? When I go back and look, the biggest one is 42, the smallest one is 26. I do not have points outside that range. Doing the same thing for the rural group. Q3 minus Q1 is going to be 45.5 minus 35.5, which is 10. Multiply that by 1.5 to get 15. And then I say 45.5 plus 15 and 35.5 minus 15. So this is going to be 20.5, and this is going to be 60.5. I do not have points outside of that range, so there are no outliers. No outliers in either direction. Letter F, describe how a researcher might use schools as clusters to gather data in a given county. The way a cluster sample works is I will randomly pick some school in a county. I randomly pick a school in a county, and then I survey all the students at that school. Since the school was randomly selected, it's reasonable to apply your data to the county at large. Now, if you think that your schools are not representative of your county, you might want to choose several schools from that county or even stratify before I get my cluster. Letter G. The heart of letter G is this question about confounding variables. So it's possible that there's some other reason why the rural students eat more calories that is not just described by a home-cooked meal. So for example, maybe they're more active, and so they eat larger portions if they live out in the country. So we're unsure if the reason they ate more calories was because they're more active or because they're eating these home cooked meals. That's a confounding variable. And if that's linked to where they live, it's going to be hard to tease out the difference just from the information we have there. Letter H. So now we have a question about how these organic supermarkets influence things, especially combined with eating more at home. The reason these two variables are confounded together is because we can't tell if the difference is because of their access to the supermarket and the lower calorie or healthier food there, or because of the increase in stay-at-home meals where they're perhaps more carb heavy. Letter I talks about how you would get a simple random sample. So basically, I'm going to take a list of all the ninth graders and I'm going to number them off 1, 2, 3, 4, all the way up to N. Use a random number generator or a random table to pick a number, survey that student, repeat the process, skip the repeats, and go until you have the desired sample size. Don't forget to say something about skipping the repeated numbers. Letter J, describe one variable that might be important to create strata and why you would choose that variable. Perhaps one is gender, and talking about why you would choose that variable is because you think that there's a difference in how many calories guys eat and how many calories girls eat, and there's some variability when I include them together. If I separate boys and girls, that reduces that variability that's created by the gender differences in caloric consumption. And what inference procedure could I use to compare the two groups? These are means. And so I would use a means test, a means procedure on two samples, and I would use a two-sample t-test because I don't know the true standard deviation. I only have the sample standard deviation from my data.